Hi guys, this is Dr. Manjuna Channapgod from Anveshana Academy, Bangalore, India. Dear students, in the previous class we discussed some numericals on diesel cycle. Today I will move towards next numerical on diesel cycle. Okay, so numerical on diesel cycle. Okay, this is our fourth numerical on diesel cycle. Dear students, first I will read the problem, then I will solve this numerical step by step. An air standard diesel cycle has a compression ratio of 16 full stop. The temperature before compression is 27 degrees Celsius and the temperature after expansion is 627 degrees Celsius full stop. Determine first one, the net work output per unit mass of air. Second one, thermal efficiency. Third one, specific air consumption in kg per kilowatt hour. This is the problem he has given. Again, you can see, dear students, now the problem is related to a standard diesel cycle. So, and he has given some basic data. With help of that basic data, what I have to do, I need to calculate the work done, thermal efficiency and specific air consumption per kg kilowatt hour. So, this is what, then problem is related to what, diesel engine, so, or diesel cycle, that I have to mark now. So, first one, what I have to do, dear students, that is very important step. The first step is I need to list out them given data with help of what, P1, PV and TS diagram for a diesel cycle. Okay, so what all the things he has given, I will list out here now. So he has given compression ratio, that is how much, 16. That's compression ratio is, no, we already know the definition of compression ratio. It is nothing but what, V1 by V2 is equal to 16 he has given. You can take capital RC as the compression ratio notation. Fine. Then before compression, the temperature of air is 27 degrees Celsius. That I will mark it here. That is T1 is equal to 27 degree Celsius. Okay, fine. Then next, that you can convert it into Kelvin by adding plus 273. Then what happens now? You are going to get 300 Kelvin. That is fine. The next, at the end of the or after expansion process, the temperature is going to retain as 627 degrees Celsius. That is nothing but what, end of expansion, we can call it as a T4, that I will show you. That is how much he is telling, 627 degrees Celsius. Again we add 273 to convert it into Kelvin. So you are going to get T4 is equal to 900 Kelvin, and is asking to calculate the work output per unit mass of air. So what I will do, I will take M equal to 1 kg, that unit mass. Okay, now to calculate the work output, what is the formula, general formula we know, that is that work output is equal to QS minus QR, heat supplied minus heat rejection. What is QS, that I will show here now, dear students. Now, so this is the thing he has given. I will come to this point. So you can analyze the problem with help of a schematic diagram or working diagram. So now what is, this is a diesel cycle. Fine. Compression ratio he has given, V1 is equal to V1 by V2 is equal to RC, that is equal to 16. Initial temperature is 300 Kelvin. Then T1 you can mark, T4 is equal to 627 degrees Celsius. Then what actually is asking, dear students, is asking to calculate the work output. That means what is supplying air into the inlet manifold. How much air he is supplying? 1 kg of air he is supplying. That is nothing but mass. Okay. Then you have to calculate, for supplying 1 kg of mass, how much work we can get from the engine. That work where we are going to get, work we are going to get at crankshaft. That is nothing but what, how much amount of work. That work is represented as a capital W by supplying 1 kg of air. Fine. So next, second one, thermal efficiency. Now dear students, we know already what is the efficiency, output to the input. Input what we are giving now, here giving input as a heat supply. When it comes to diesel engine, we are supplying heat as an input, then we are getting work as an output. So therefore what is efficiency now, how I can write it now, efficiency is nothing but what, work done divided by heat supplied. So that is what second for our finding. So I can calculate the work done, efficiency of the engine by using work done per heat supplied. One thing. Then specific air consumption, then how much of air is going to consume to produce 1 kilowatt hour of power, that we need to calculate. This is our finding now. So now you can see the PV diagram. So pressure versus volume diagram, dear students, you can see here now. So with help of this PV diagram I can mark here now. What is point 1? Before compression, that is T1. How much it is? 27 degrees Celsius, that I have marked it here now. Next, end of the compression, but he has not given T2. I will mark it as it is here now. Again T3, he is going to supply certain amount of heat, that also is not at all given. I will keep as it is. But he has given T4. T4 what actually is telling? After expansion. After expansion means what? 3 to 4 is the expansion. Expansion will start from 3 and it is going to end with what? 4. So that means what he has given after expansion means what he has given? Temperature here is a 627 degrees Celsius. Okay, these all things he has given, but he is asking to calculate all three parameters: work done, thermal efficiency and specific air consumption. To calculate that work done, we know the equation. What is that? That work output is equal to Qs minus Qr. What is Qs, dear students? Now where you are supplying heat? When it comes to diesel cycle, you are going to supply heat at a constant pressure at 2 to 3. So therefore Qs is nothing but what? MCP, specific heat at constant pressure, highest temperature T3 minus T2. That I have written it here now. Okay, fine. Next, here it is a heat addition, but here where heat is getting rejected? At constant volume process. Where it is now? Highest temperature is T4, lowest temperature is T1. So therefore M into how the heat is getting rejected? At constant volume. So I will take it here CV. Specific heat at constant volume, that is CV, M into CV. Then T4 minus T1. I will write the equation where M equal to 1, right? Where M is equal to 1, right? That is a constant, you can neglect. So therefore what I can do now? M will be get cancelled. You can neglect, it is a 1, right? Cp is equal to T3 minus T2 minus T4 minus T1. So dear students, by seeing the formula, what I can understand now, to calculate first finding is what? Work output. To calculate that work output, what I should know then? I should know the value of T3, T2, T4 and T1. To calculate that I require all the temperatures. All the temperatures I need to calculate. All the temperature means what? T1, T2, T3, T4. But he has given some data, but other data I need to calculate. But here T1 he has given, T4 he has given. But T2 and T3 is not at all given. That I can calculate with the help of what? Pressure ratio. How it is, that you can see here now, dear students. Okay, fine. Dear students, while solving this problem, just I will tell some important factors. They are directly influencing the performance of the diesel cycle. What are those? That just I will list out here, but I will not discuss in detail. The ratio of specific heats. It play an important role on the performance of the diesel cycle. Compression ratio. How it is compression ratio? If the compression ratio is increased, then efficiency of the engine is going to increase. Hence, higher compression ratio engines will give more power, more thermal efficiency and less emissions, we can see. Next, specific heat also affect on the performance of the diesel cycle or diesel engine. Initial temperatures and final temperature, these all are important parameters. They are going to affect on the performance of the diesel engine. Just I told you, dear students, because these all initial temperature, compression ratio, specific heat ratio, final temperature we are calculating here now. These all parameters, they are directly affecting on the performance of the engine. For your understanding, just I told. Okay, that you have to keep it in mind. Okay, now so I will come to the problem. Now what I have to do then? I have to list out the given data. First step by step. What is first step? I need to identify the given data and I have to list out. Then I need to calculate the T2 value. But dear students, no need to calculate T4 here. You need to calculate the T3 because T4 he has given in the problem itself. Okay, need to calculate T2 and T3. But T1 he has given. T1, T4 he has given, but T2, T3 is not given. That I need to calculate. With help of these all temperatures, what I have to do then? I need to calculate work output. That is, work output is equal to what? That I already told, Qs minus Qr. Second one, thermal efficiency. What is thermal efficiency? Thermal efficiency is nothing but what? Ratio of work done to the heat supplied. Then last one is I need to calculate the specific air consumption. That is SA, specific air consumption, SAC you can call. These are the steps I need to follow to solve this numerical. Now, so as I told, all temperatures T1, T4 he has given, T2, T3 I need to calculate. With help of this I can calculate work done, I can calculate thermal efficiency, I can calculate the air consumption rate also. This stuff you already I explained you dear students now. Okay, so calculate T4, but T4 is not required, T3 is required. Work output, thermal efficiency and specific air consumption. What is this the definition? The definition I have given here, just you can have a look dear students. Okay, now so first step is what? I have to list out the given data as I told. What is the things he has given? He has given compression ratio that you can mark it as a small rc or capital RC, it's up to you. That is equal to 16 he has given. Temperature before compression, that is T1 27 degrees Celsius he has given. T4 he has given 627, that we can convert it into Kelvin, so it becomes T1 becomes 300, T4 becomes 900 Kelvin. Now what I have to do then? First step is what? I need to calculate the work done per unit mass of air. That means what? M equal to 1 kg. So to calculate that work done, as I told these students, what is the work done equation? That is nothing but what? Qs minus Qr. What is Qs? Heat supplied. At what? T4 minus T1. So I required, T3 minus T2. I should know the value of T3 and T2. Here QR means what? MCV into T4 minus T1. So I required all the temperature. So for that what I have to do? To calculate the work done, I should know the value of all temperature. So for that what I will do? I will go with what? Step by step. Process 1 to 2. That's nothing but what? Isentropic compression, or we can call it adiabatic compression. There we know the temperature ratio versus volume, that is nothing but what? T2 by T1 is equal to RC to the power of gamma minus 1. Dear students, but here T1 is given but T2 is not at all given. I will try to take the value of T2 outside. So therefore T2 is equal to T1, it will come right side. T2 is equal to T1 into RC to the power of what? Gamma minus 1. What is T2? Now, so to calculate the T2, I need to substitute the value of T1. T1 is equal to 300 Kelvin, RC is equal to 16, then gamma is equal to 1.4, that is for air, that is standard, minus 1. Do simplification, you are going to get the value of T2 is equal to 909.4 Kelvin. So therefore, we got the value of T2 as 909.4 Kelvin. That is what T2. Now, one more temperature I need to calculate, that is T3. How to calculate the T3? That you can see here now. I will go with what? Where you can see now, where I can get that value. Just a minute. Where I can get the value? At process 2 to 3. At process 2 to 3, I can get the value of T2 I have already calculated. With the help of this process 2 to 3, what I can do? I can calculate the value of T3. How to calculate the T3? You can see, to calculate T3, what I have to do? I have to go with 3 to 4 process also. You can see now, it's up to, now I can go with 2 to 3 or else 3 to 4 also we can go. Why it's so? Because he has given the value of T4. With the help of 3 to 4 process, I can calculate the value of T3, or else I can calculate the T3 value with the help of what? 2 and 3. But what I will do? I will go with what? 3 to 4, because I know the standard equation, pressure variation equation, and temperature variation with volume, that also I know here now. What is that now? Now I will go with the isentropic expansion, that is what? 3 to 4. So that how I can write now? Variation of temperature, that is T3 by T4 is equal to V4 by V3 to the power of what? Gamma minus 1. So what is T3? I don't know. I will keep it as it is. But T4 he has given in the problem itself, that is 900 Kelvin. Then V4 by V3. V4 by V3. You can see the figure, dear students, where V4 is equal to V1. That you can see here now. See here now. So what is that now? Just you can draw a vertical line. So you can see here now V4 is equal to V1. That I will substitute here now. So therefore V4 is equal to V1. So wherever V4 is there, right, substitute, replace that V4 by V1. So V1 by V3 to the power of what? Gamma minus 1. T3 by, now I will substitute T3 by 900 Kelvin is equal to, but this how I can write it now? This V1 by V3 I can write it now, V1 by V2, V2 by V3. So here dear students, V2 will get cancelled. Again it will remains as a V1 by V3, but I can write it in another way. I have written it here now. So this already I have explained many times. Okay, what is V1 by V2? V1 by V2 is nothing but what? We know already, RC is equal to V1 by V2. Next here it is V2 by V3 is there. V2 by V3 is there. But we know already, dear students, what is that? Cutoff ratio is equal to V3 by V2. So what I can do now? V2 by V3 I can write it here 1 by rho. So therefore V2 by V3 is nothing but what? Sorry, V2 by V3 is equal, already sorry. already he has given, directly he has given. 1 minute. Okay, so now V2 by V3, we know already V2 by V3 is equal to what? Gamma, sorry, cutoff ratio, that is rho. So that I have taken it here now. To the 4 of what? Gamma minus 1. So T3, I will write it like this only. Now I will go towards, because at the left side I don't know the value of T3. At right side you can see rho also I don't know, but two unknowns are there, but I can't solve this equation here itself. I will keep it as it is, then I will go to the next process, that is what? 2 to 3. What is the 2 to 3? Variation of that we know already. V2 by T2 is equal to V3 by T3. Here T3 I don't know. I will try to take the value of T3 as T3 is equal to T2 into V3 by V2. What is V3 by V2, dear students? As I told, that is rho, right? Yes, dear students, a small correction here now. Okay, so this is RC, but 1 divided by rho it is now. 1 divided by rho, just to make it RC into 1 divided by rho. Because, small correction dear students, sorry. We know V3 by V2 is equal to cutoff ratio. So V2 by V3 is equal to 1 by rho. But so here it is V2 by V3 is there. What is the value of V2 by V3? That is 1 by rho. So hence RC into, this is what? RC into what is that? V2 by V3 is there, but V2 by V3 value is 1 by 1 divided by gamma into 1 divided by rho to the 4 of what? Gamma minus 1. Okay, so now that you have to make it correction. Sorry. Next, constant pressure heat addition. If it's so constant pressure heat addition, we know already V2 by T2 is equal to V3 by T3. So therefore, I will try to take the value of a T3 outside. So therefore, T3 is equal to T2 into V3 by V2. As I told, what is V3 by V2? V3 by V2 is nothing but what? Rho. Yes, I will substitute here. T3 is equal to T2 into rho. But here I got the value of T3 is equal to what? T2 into rho. But here it is what? So can I simplify? T3. So what I will do? I will substitute this T3 value here. Whatever I got it, right? This I will substitute in this equation. Then what will happen? You can see now. So therefore T3 by 900 is equal to, what is the value of RC? What is the value of RC? That way of RC 16. But rho I don't know. I will keep it here now. It is 16 divided by rho. That means what? 1 divided by rho into the 4 of what? 1.4 minus 1. So I will do simplification. I will try to take the value of T3 outside. So therefore T3 is equal to 900 into the 16 divided by rho to the 4 of what? 0.4. 1 minute. Okay, fine. Now, so now T3 I simplified this one by substituting all the values. I got this, but this T3 value is nothing but T2 to the T2 into rho. So they say for T2 into rho, T3 value is equal to 900. I will simplify, but here you can see at the left side and right side, rho is the only unknown. By simplification, I can get the value of what? Rho easily. Do simplification, then what you are going to get? You are going to get the value of what? Rho is equal to 2.19, dear students. Okay, because we know T3 is equal to this much. What is the value of T3? T3 is equal to T2 into rho. So that's T2 into rho, and I am going to simplify. Just you can simplify here step by step. Dear students, you are going to get the value of rho is equal to 2.19. That is what rho value. Next, to find now, once you know the value of rho, now we can easily calculate the value of what? T3. How to calculate T3? Because we know already T3 is equal to T2 into rho. T2 you already calculated. Yes, I will use the same equation. T3 is equal to T2 into rho. T2 we have already calculated, that is 999.4 into rho, that is 2.19. So by simplifying these two, what I will get? I am going to get the value of T3. The T3 is equal to 1991.6 Kelvin. This is what? T3 value. Okay, next, once you got the value of T3, right? Then what you have done now? T1 he has given, T4 he has given, but what you have done? You have calculated T2 and T3. To calculate the work done, efficiency and all these things, I should know the value of what? These all temperature. Just now I calculated these all values. Then what I will do? I will calculate the efficiency or work done. How it is, that you can see now. Now I will calculate both. To calculate the work done, I should know the value of heat supplied, that is Q in and Q out. To calculate the Q in, what is the formula? Constant pressure heat addition, right? That is Q in is equal to Cp into T3 minus T2. What is Cp? the specific heat of air at constant pressure is 1.005 kilojoules per kg Kelvin multiplied with T3 1991.6 minus 909.4 Kelvin. Do simplification, you are going to get heat supplied or Q in is equal to 1087.6 kilojoules per kg. Similarly, I need to calculate the value of what? Heat rejection. We know the formula. What is that? Q out is equal to CV into T4 minus T1. Substitute now. CV, specific heat of air at constant volume is 0.718 kilojoules per kg Kelvin multiplied with 900 he has given in the problem itself minus 300. You are going to get heat rejection is 430.8 kilojoules per kg Kelvin. Now once you know the value of heat rejection, once you know the value of heat supplied, with the help of these two data I can calculate the work done. What is that work done equation? That is W net is equal to Q in minus Q out. So what is Q1? That is 1087.6, that is Q out 430.8 kilojoules per kg. Then do simplification, we are going to get work net is equal to 656.8 kilojoules per kg. Hence the work done by the engine or diesel cycle is 656.8 kilojoules per kg of air. It is doing this much amount of work. That is first finding is done. Next, what is second finding? Second finding is I need to calculate the efficiency. What is how to calculate the efficiency now? We know the formula. What is that? Efficiency of diesel cycle is equal to net work to the heat supplied. That is simple. What is net work? That we already calculated here. That is 656.8 divided by Q in. Q in is equal to how much? 1087. That I will substitute. Do simplification. We are going to get 60.4% is the efficiency of the diesel cycle. It is working for only 60.4% efficient, but other thing is getting waste. That is okay. Now specific air consumption. How to calculate that? To calculate that, we know per kilowatt hour he is asking. Hour means what? Whatever we got it, right? Kilojoules per kg per second we have, but 1 hour is equal to how much seconds? 3600. So 3600 divided by work net. So then what? How much we are getting now? This much, 5.48 kg per kilowatt hour. That is something what? Specific air consumption. That is third finding. Okay, so this is the how to solve the problem. Final answers you have to mark, dear students. Now what is final answers now? Network output is 658.8 kilojoules per kg. Then thermal efficiency is 60.39 or 60.4%. Then specific air consumption is 5.48 kg per kilowatt hour. These are the final answers you have to mark at the last, dear students. Dear students, I hope you understood this problem. If you have any problem, if you have any doubts, you can ask me by putting comment in comment box. Dear students, here with I request you, please do subscribe my channel, do comment, like and share. Support Anveshana Academy. Thank you.